The goal is to evenly kind of grind through the chip. There it goes. Look at that. Look at that. Beautiful. In today's video, I'm going to show you guys how to prep this iPhone 8 Plus donor board for a CPU swap. But the special thing about this video is I'm going to show you the new technique using this grinding pen. This is a Qianli Grinding Pen, and I'm going to grind away this CPU, but it's not the way you think it is. I'm going to show you guys a new technique that I've developed. I've been experimenting with different methods to try to remove the CPU without damaging the surrounding components, bumping a resistor or breaking a coil or ripping pads. So this technique makes it really easy to remove a CPU, a baseband CPU, a Wi-Fi chip, a baseband PMU, any chip that's underfilled, that's surrounded by components, and makes it really hard to enter your tool underneath to pop it off. This technique makes it really easy, but it does require hand skills, and I do recommend you practice it a few times before you do it on a live board, because it is really risky if you do it the wrong way. So make sure you stick around for the full video and pay attention to every step that I do, and you'll see how this works. Also, if you need any donor boards for either CPU swaps, bottom board swap, or you need to pick parts off of it like coils, components, filters, or just need a practice board, I am able to source some of these iCloud locked donor boards. Like for example, this one, it is pretty much, these are untouched donor boards that boot up and you're able to use them for parts. These are not fully working, these are locked. So you cannot use them for functionality, but you can use them for, like I said, picking parts or testing and stuff like that. And these often come packaged like these. So if you need to buy some donor boards, check out the links down below and submit your request. We'll send you a quote for the donor boards and the shipping. Currently, USA customers only, no international, but maybe in the future we'll think about it depending on how well this goes. Also, if you want to support the channel, check out the links down below so you can get yourself a Christmas sweater like this one. I will link it down below. The Christmas holidays are coming up, so make sure you guys get yourself one of these, support the channel. Make sure you guys are subscribing to the channel, smashing the like button, and sharing this video, because this is going to be a really useful video. So let's go ahead and get started. So everything you need for this video is basically going to be one of these. This is, like I said, the Qianli Grinding Pen, and you want to get this head for it. So it's basically a disc at the end, and then it spins. So this is the head you want on your grinding pen. You're gonna need a board holder, of course. You're gonna need a working donor board, and then you will need a spatula type of tool with a really thin blade. The actual blade itself doesn't really matter. I prefer this one. It's pretty much a flat tip at the end, like that. But pretty much there's a few variations of this. So I will link to a few different versions of these, and then you'll have to, I do recommend you sand it down as well. I don't know if you guys noticed, it is silver towards the end because I use sandpaper to sand it down. So I'll link to everything you need down below. So let's go under the microscope to see pretty much what we got to do next. All right, so I've already have the shield and everything removed, pretty much ready to go. But this is basically what I was saying was the issue. You can see there's a ton of little resistors all around. And if you were to bump any of the resistors trying to remove the CPU, what's going to happen is you're going to have no power issues or rebooting or a bunch of who knows what kind of problems you're going to have. So you have to be able to remove the CPU, prep it and everything without pretty much disturbing anything else. So this is, like I said, an iPhone 8 Plus. So you can see the 811 CPU. But this technique works on pretty much any phone, any chip, as long as you understand the concept of what we're doing. So when you're doing a CPU swap, the donor board that you're going to swap into, the target source, the donor board that you're going to swap the customer's CPU onto, I would recommend it'd be data only jobs. That has to be a fully working phone. But removing the CPU can be very, not destructive, but can be very stressful to the board, and you can cause all kinds of problems because the amount of heat required to pop a CPU off and all that stuff. So the trick is the donor board, you have to be real delicate of the board because that's what you want to save. The customer's board, you only have to worry about the CPU or whatever chip you're trying to remove. that you're trying to keep the original of. You know, destroying the surrounding components to like better access the CPU, doesn't matter what happens to all the resistors. Ideally, you don't want to purposely destroy them because you might need it in case you do end up bumping one at some point. Hopefully you have more donor boards, but which, you know, if you need to buy more, let me know. Link down below to submit your quote request for the donors. But imagine, you know, this donor, we got to pull this chip off and then keep all these components as is, undisturbed. Whereas the customer's board, we just need the CPU. So we could actually technically wipe out all these. So we could easily insert a tool into underneath the CPU and pop it off without damaging the CPU. So it's kind of like, there's basically two techniques to approaching each board. And in this case, I'm going to show you guys how to approach the donor board. Now this technique, like I said, works on pretty much any chip you're trying to remove that you don't need the chip itself anymore, but you want to preserve the surrounding board and stuff. So I do this a lot for PMIC as well. Since PMIC, at least on this board, you can see how PMIC is on the back side. You can see all the components, how tight it is around it. So to get that PMIC off, then, you know, you're gonna have to bump some of those components and stuff. You know, the NAND, technically the NAND as well, but usually NAND, you have giant gaps on the side. So maybe not that useful. Like I said, pretty much anything. The goal here is to preserve the board's integrity so it's still a functional board without a CPU. So step one is to clean off all the underfill around the chip. Now in this case, they're actually not that much. So let's go ahead and start it by using 250 Celsius, but there's not much in here. Using a number 11 scalpel blade. Now this blade actually, it's a little worn out. Let me swap it out. So these are the blades I use. I've tried a few different number 11 blades. The ones from Mobile Centric seem to be the best. And I use a scalpel handle. This is a special handle that is weighted, it's heavy, it's round, so it gives you a good solid grip. So I really like that one. And then what we do is pop the new blade out. Be real careful, these things are sharp. Pretty sure these are the ones they use to cut into your body for surgery. Maybe not. We use these to cut into motherboards. So put the old blade into the packaging and then go ahead and throw it away. Hopefully nobody gets pricked by that. All right, let's go back. So 250 Celsius is hot enough to soften the underfill, but not melt anything. Now we're a little lucky here. There's not much underfill under the CPU. I see some here between this coil. Now every step I'm showing you guys is crucial. So new blade, so you can get pretty much as much underfill as you can out. Clearing the underfill around the CPU. Make sure you guys are watching the whole video. Okay, I think I got that stuff. Now if you want to be if you're a little paranoid, you could also clear surrounding chips underfill as well. Like even this chip might be useful to use this technique to remove the chip because you're going to replace it with a new one. You know, there's a lot of capacitors around it and no easy way to get underneath. Oh, there's an opening here. You know, but anytime you don't want to risk it. Now, you know, I've been soldering for almost 7 years now, so I do have really good hand control. You know, these micro movements under the scope. So just keep that in mind. I have lots of experience, you know, doing this basically 24/7 a day. Oh, 24/7 is 24 hours, 7 days a week, which I do work 7 days a week. So I have a lot of hours under my belt as far as soldering. So although, what I'm showing you guys may look easy per se, don't just assume it is easy. You need to practice it and make sure, when you practice on a board that everything goes smooth and you're able to verify that whatever you did worked. So if you're gonna do this to, do a CPU swap, do a full CPU swap on, across 2 donors and make sure everything works. Don't just watch my video and then go for it on a customer's board. You need to understand what we're doing here exactly. You need to understand how to control your heats, how to control your blade, and in this case, how to control the little grinding pen that we're going to use here in a bit. So I am scratching a little bit of the copper surface, which is fine. No big deal. But yeah, I think that's pretty much it. That was really easy. Now, just for a little bit of peace of mind, let me clear some of the underfill between these coils. So when there's extreme heats near it, it doesn't float or come loose. And having a sharp blade lets you fit in between here without damaging the coil itself. Now, this board, I did test it before I went on camera, so this is confirmed to boot up and everything. I highly recommend you be thorough with your workflow, test, make sure you're not doing stuff without testing, and then you end up doing a bunch of work for no reason. Also, I'm not going to show the full CPU swap in this video. Let me know if you guys want to see a full, from nothing CPU swap, because that's going to be several hours. Who knows, maybe 5 hours to go through the full process. Prepping the donor, pulling the chips, prepping the chips, reballing everything, placing it, test, and then with all the tests in between to make sure nothing went wrong. It's a huge process. I mean, it sounds like easy, four steps, but each one is its own little adventure. But I guess if you guys want to see it, I'll do it. Let me know in the comments what you guys think. Okay, so I've cleared out all the underfill, everything's ready to go. And then on this little pen, like I said, this is a little wheel. The technique here is we're gonna grind away part of the chip. This is how you would do it before this technique. Essentially, slide between the components and under the CPU to pop it off, but that gets really tricky, especially in certain cases. There's like pretty much, you're pretty much guaranteed to bump these components and you have to put them back later, or you pop off a few caps if they're enough in a row. Like here, you could probably remove these two and be able to fit your tool, and then from there you can work your way, or maybe pop these two off, or maybe you have to then look at ZXW and stuff to see which caps have a leg on ground, which are likely not needed. But in this case, what we're gonna do, we're gonna grind an X across the CPU. So on this pen, Qianli, I'm gonna double tap the power button, and we're pretty much at full blast. You can adjust low, medium, high, super high, ultra high, probably. All right, so this is basically what we're gonna do, is grind away an X. Now you do have to, you can do an X or a plus technically. I do an X in this case because it pretty much, I can go from corner to corner with pretty much nothing. If I do it this way, I'm probably gonna hit that coil right there. See if I get to this end, I'll reach the coil. The goal is to evenly kind of grind through the chip. And you do want to also make it all the way to the edge. And it doesn't have to be a perfect straight line. The goal is to grind all the way until you see the pads, which I'll show you what that looks like. So pay attention. Now before I continue, let's start the other direction as well, just so I don't go too deep on the other end. And then make sure you're holding the grinding pen with 2 fingers, or 2 hands I mean, using multiple fingers to stabilize it. So just for reference, here I'm going to show you kind of how I'm doing it. I'm holding both hands and essentially, you know, my hands are planted on my bench and essentially I'm just going like this. You see that? So do that under the scope because you need to see exactly where your pen is going. And then don't focus too much time in one spot. Keep spreading around. Also, you know, take a break, blow away some of the dust, and then come back, you know, look at it. You know, these CPUs or components or whatever, they're multi-layer, so you'll see like different colors and stuff. Double tap the power button and then come back. Also, it's good to make a thicker groove so you kind of get a better look inside. And essentially what you're looking for is these silver round pads. Like if you know what the pads look like underneath, that's what you're looking for, but in silver. You'll see it here in a second. Now you got to do it evenly, so don't just spend too much time on one side without neglecting the other. So you see copper. This is just from inside the chip. I'm gonna get this corner here. Now it's gonna look kind of like this, except this is, I believe, the top of the RAM, or the RAM section. So basically look for that, but once you go deeper, and you can see that kind of ends right there at the end, around the edges, which is kind of what RAM layout it looks like. Just keep grinding. Okay, looks pretty gnarly, right? So we still haven't reached the surface of the board. But don't worry, we'll get there soon. And you really got to be careful. Like I said, this is something you got to practice so you can kind of tell, like, oh, did I go too far or not? Just like on the SE 2020 jumper solution, there's a ton of people who watched my video and kind of destroyed the board because they couldn't recognize how deep they were going and they went beyond the layer they were supposed to reach. Also be mindful of those surrounding components. And the whole idea is not to damage the surrounding components, so Still gotta keep that in mind. All right, I see some blue. That's gonna be most likely the top of the CPU. You know, below the RAM. So pretty much we probably grinded past the RAM already. And then that blue is, you want to get past that blue layer right here. Now the CPU does take the longest. You know, when doing baseband CPU or baseband PMU or PMIC is way faster. CPU is super thick compared to those. So this one does take longer, but. And then, see the blue is kind of going away, and now we're seeing gold. Oh, there he is. You see those pads right there? That's where we want to reach. So that's the point. You want to stop right here. See some more. You want to be real careful once you get to that point, because that's the board. There's more of it sticking out. So you guys seeing that? So now let's continue on the other side. And then we're coming close to seeing the magic of this technique. And it'll all make sense once you get to it. You're like, oh, now I know why. That makes sense. And that's pretty much, that was my revelation when I kind of came up with this technique, is, you know, how do you get this chip off without bumping all those resistors? Because those pretty much resistor next to CPU, you know those are going to be important. And how do you do it without getting it off? So the most common technique people use to, you know, prep a board, you know, so that it doesn't damage the pads and it doesn't damage surrounding components, it's a CNC. But you know, CNC is a giant machine. You got to program it properly and calibrate it and stuff. So, you know, it's not a easy thing to handle. Now, another thing I saw that kind of helped me come up with this was, you know, people are grinding away display chips, but they're doing it a different way. The display chips, they're facing this down and just grinding away, literally just grinding away the whole chip. That would take way too long. So my concept was, I'll show you in a second. You guys gotta stick around for the full video because it'll all make sense. I guess drop in the comments, are you getting do you see where I'm going at with this technique? Is it starting to make sense? Are you wishing you came up with it first? Because really, once you see it, you're like, oh, okay. And it's not that hard. You just gotta practice it a few times so you can know, you know, how far you've gone. You know, I even had my tech learn this technique, and he's been doing it for bottom board swaps for a few jobs now, and it's pretty simple once you do it a few times. I'm so glad I got a new grinding pen because the other one sucked. I almost never used it. It was the Mijing one, I think. All right, we're getting close. I think it might be time to give it a try. So these are the pads of the board. Now here's a little tricky because it could be RAM, it could be the board, but I pretty much exposed a big portion of it. All right, let's grind away some of this side a little more. Maybe that cap might be damaged, maybe not. Grind away a little more over here. I think I pretty much, let's get this corner over here as well. Like I said, these pads here are the RAM. I don't think I could get any deeper than that without possibly damaging the board. You know, there's going to be a risk of some pads may be damaged, but if it's just one, you know, out of many, there's a trade-off, you know, to this technique and everything. So now I'm cleaning with a toothbrush and ISO so that we can get a clear look. All right, now here's the big reveal. We're gonna lift the chip from the inside. That makes sense? We're going to lift it from where there's no risk of bumping components. So that's pretty much the trick here. So we're gonna use 380 Celsius with 50% air, as you can see. And we're gonna literally insert our tool into one of these points here and lift the CPU with zero risk of the surrounding components. The tricky part is also finding an entry point. So you do have to heat it up for a bit. I'm gonna add a little more flux now that it's been pretty hot. I'm also being really delicate right now because I really don't want to mess this up. Alright. You can even chip away at some of these pieces. Yeah, I got that chunk off. No, we don't care what happens to the CPU, right? So as long as we get the CPU off. Now this is where it gets tricky because you gotta get in under CPU but still above the board. Oh, there it goes. There it goes. Look at that. Look at that. Beautiful. And this is why you gotta kind of cut through all the different quadrants because you want to break off in chunks. And let me add a little more flux. So now that we got that big chunk off, we can just come in with our flat blade and just slide right in underneath with no worries about the surrounding components. And now that we've kind of chopped it up into 4 quadrants, you know, the heat needed to separate one quadrant is going to be smaller than removing one whole chip. And there it is. So what do you guys think? My VCC grinding technique? Make sure you guys credit me. But I guess I can't really control you guys not crediting me. But let me know in the comments, what do you guys think? Are you gonna try it? Is it too risky? Do you have a better technique? Now there's still a chance to float PMIC underneath, but that's a lot easier to deal with than a CPU. Oh, there's like a chunk of the CPU here stuck. And last piece. So you can see what I'm doing. I'm entering in this flat section here. That way I know I can go underneath without ripping pads. Look at that, this piece is coming off. And there's one more piece here. All right, so CPU is gone. Let's see if we can put this back together. Obviously, this is not going to be the customer CPU. This is the donor board CPU, and we don't need these pieces for data. But you can see pretty much we've chopped it up so we can get it off easier. And we can have an entry point in the center instead of on the outside. Now to inspect the board. So, did I go too deep there? We'll see. But, you know, basically here you can see the X of my grinding pen. The only spot is sketchy here. We'll have to figure out once we get the underfill removed. So, step one is to prep the pads. I'm going to use some low melt 1/38 solder wire. This makes it easier to clean after. So let me turn on my fume extractor, link in the video description. This is my DIY fume extractor. It's about $100. Now, I do have, the nice thing about donor boards is they're cheap. So if you mess one up, you could always just get another one. You know, there's very little risk to this, and as far as you might have to buy another donor board, worst case. But yeah. Now if you're doing something else, like a PMIC, then that's going to be a bigger deal if you damage that board. Okay, let me focus a little bit. So what do you guys think down below? Comment your thoughts. Have you ever tried any other techniques? Which one do you find is best? Do you plan on trying this one? Highly recommend these knife tips. Makes cleaning underfill so easy. It's hot and you could scrape away a lot of the underfill. Okay, so that little corner doesn't look good, to be honest. But I hope at least you kind of got the concept of the technique. Like I said, I've done this several times successfully, and I guess shouldn't expect 100% success rate, but the idea is to show you guys the concept, and then who knows, maybe you guys will come up a variation of this based on this technique. So if someone comes up with a better idea, you know, like I mentioned, you can technically do a CNC, which, sure, I mean, if you want to spend $2,000 on a machine and then have to tinker with that thing until you figure out how it works, or if you just kind of master the hand technique of this one, you'll probably, yeah, that's all right. So those two pads definitely didn't survive. Well, let's see. There is a lot of underfill here, so maybe there's a chance. And it could be either ground too. There's a lot of ground on their CPU anyway. So I'm using my blade to try to poke away the chunks of underfill in this area. I know what it is, because I'm on camera. Of course, that's when it doesn't work as I want it to. And I do remember kind of going back and forth a lot in this area. Maybe, yeah, it's an excuse, but maybe I was just talking too much and not realizing I was overdoing it. So, all right. Well, while the board is hot, let me just clear out the rest of these chunks of underfill. I don't want to waste this opportunity. Just, you know, if the board is still good, you know, let's say those are ground pads, or maybe it's a, you know, front camera pad or something that I don't need for data, then I can just UV mask it all off and continue on. If it is like a I2C line that is, you know, required for data, clock line or something, I don't know, then I'm screwed and I'll have to just get another donor and start the process again off camera, so I don't have the pressure or distraction of trying to explain every step. Because one of the things I don't think people realize is when you're filming these, if you want to make a good video, you do have to kind of talk in it. If you're not talking, then kind of video gets boring. So I'm talking now to fill time while I do this boring task of carrying out this underfill. Oops, I scratched the board. Man, I really hate these chunks in here. All right. Those of you who do a lot of CPU swaps, you just leave this underfill section, these little squares. You leave that underfill there, or you clear those out as well? Because I always clear them out. But I don't know, maybe it's not necessary. I would be interested in hearing any techniques to clearing underfill faster than what it's taking me. I think that's one of the biggest time-consuming tasks in here. I'm just prepping this so the CPU can sit flat afterwards. Yeah, I would say if I were to rate this grinding, VCC grinding method, I would say this is a solid 8 out of 10 as far as this specific job on this specific board, because it did scratch the hell out of that section right there. But on this crane, it's still usable. Praying to the solder gods. Are the solder gods listening right now? Or are they asleep? Because it is pretty late right now. Alright, that's enough. That was mostly my OCD kicking in, where I want to just do everything perfect. Let's see, what I like to do is soak the board and then lay a clean cloth and then scrub. And you can see it kind of picks up a lot of the flux and stuff. All right, let me pull up ZXW and see if I wrecked this board. All right, so if we zoom in on those specific pads and we zoom in, looks like we might have dodged a bullet. All right, let's go full screen on the scope. Let's count down some of these pads. So let's start at 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. So this, I'm pretty sure this is the scratch right here. You see that red line? Pay attention to that red line. Pay attention to that. So we're good. Pretty much UV mask. Right, because pretty much the corner here, 1, 2, and then maybe this one got hit, maybe this one. Even if all these got hit, fine. As long as this one is not shorted, which is this here, we'll probably be good. I can barely miss that pad there, which we should expect the 399-ish reading in diode mode, which if you look on my meter, uh-oh. So we do have a short on the line. I'm in the wrong pad. Okay, let's take a look at another layer. All right, let me turn off the highlights. All right, so this line, all right, if I, oh, you know what? I'm pretty sure I hit that cap. Oh yeah, I pretty much killed those two caps. All right, so maybe false alarm. So we got both PP1V8. Yeah, so both of these caps are pretty much not required. So what we're gonna do is say goodbye to them. There goes one. There goes two. All right, let's check the other areas. These are fine, possibly. The other corner was this. I didn't hit none of that. And this corner was this coil. Now I do see solder balls here. Just poke them off to prevent any continuity. Now, oh, look at this fat solder ball here. And that cap broke. Let's pop it off. Better have no cap than a broken cap on a circuit. Yeah, so these underfilled components are usually not good to have solder balls, but they're coils. So typically you can they just squeeze outwards and nothing else happens. So you gotta UV mask that, UV mask this. Then let's probe this line again. Not shorted. No short, no short. You know, these are ground. And I didn't go any deeper than this first layer too, so we're pretty much good to go. I mean, that was the only sketchy part. All right, so there you go. Technique. Solder Gods woke up and gave me a chance to continue with this job. Just for good measure, let me UV mask that now. I'll have you guys here. So basically, what do you guys think about this technique? You know, I will link to my grinding pen and all my tools and everything in the video description below. Make sure you guys, if you like me sharing these techniques and tips and tricks and things that will essentially make you more money, if you're a repair shop and you're looking to improve your soldering skills, don't forget these videos. I'm making them for free. They take a ton of time, several hours. Video might be 1 hour, but in order for me to edit it, I literally have to watch it maybe at least 2-3 times in full, so I can make sure everything that I want to be in the video is there and everything I don't want in the video is cut out, and then watch it, make sure it kind of flows decently. And my wife also does a lot of the editing for my videos. So if I had to do it all by myself, I would say a good 5 hours, outside of filming, prepping the video, making the thumbnails, writing out the whole description. Keep in mind the description goes in a lot of detail, has a lot of links, so make sure you guys are checking that out, because one of the most annoying thing is people ask me questions that are answered in the video description. So make sure you guys are checking that out. Let me spread out the UV liquid. Like I said, another way, well, I don't think I said this specifically, but if you want to buy donor boards that also supports the channel, we'll ship directly to you in the US only, and there will be really good prices. Pretty much any model. Also technically any OEM parts, like housing and stuff, we can source as well. So let me know if you're interested. This is great the donor boards are great for practice, pulling chips, CPU swaps, bottom board swaps. I've been buying them from this source for years now, and they're great. You should have no issues. So we'll basically sell them to you directly. Oh crap. Yeah, I did UV mask the bottom piece. Buy 5 donor boards, you'll get free first class shipping. Buy 10 donor boards, free priority shipping. There it is. I made it up on the spot. New service I'm going to be offering, donor boards, so let me know what you guys need. Alright, let's see. Don't forget to smash the like button, that also helps out a lot. It's free. Sharing the video is free, subscribing and engaging with the video is free, so do all that. If you want to support monetarily, like I said, buy a sweater, Christmas sweater, or a t-shirt. Subscribe to my locals community. I have another video on doing a iPhone 11 baseband CPU. It's just the raw footage. Maybe I'll do a voiceover. I'll post that in the members only section, so you can kind of see that technique as well. I do recall I did bump some caps near it, but those were large caps and technically not needed. So, but yeah, overall, I think this does help, especially if you have issues bumping those little components or getting your, your spatula tool underneath a chip. That was my biggest issue with any underfilled chip, is popping off the chip without making any more damage. Yeah, but besides that scratch I did that we UV masked, I think no rip pads. Now I did forget to re-expose these pads. So, when you UV mask, you want to just cover what you need to cover, but not everything. Those are the scratched ones, so I'll just leave it as is. Alright, let's clean it up a little more. By the way, if you don't like this technique, there's an amazing thing called Don't Do It. And there you go. If you like this technique, let me know in the comments. I really want to hear you guys' feedback. I would actually prefer if you guys try it on a donor, go through it and see if you can master it, and then let me know in the comments how that went for you. I think I had my tech only try it once before I did it on a live board, and just from one he understood right away kind of what it entails, what you gotta be careful with. Understood the assignments right away. I think if you just have a brain and understand soldering, it shouldn't be an issue. So, but there's nothing I can do about not having a brain, because you're either born with one or you're not, or born without one. So, kind of help you there. Let's see. Let's get some solder on all the pads. And last thing I'm going to do is wick this board, which I also will link to my wick in the video description. It is an amazing wick. Highly recommend it for any wicking on any board you're working on. Also would recommend this soldering iron setup, Action T3B. Although I might as well reveal it now, I am getting a new soldering iron that's on the way that I'm pretty sure it also supports the same JBC tips. I won't know until it's here. I'm in the process of arranging the shipments, but Forward, the one who does the blue laser, they're gonna send me their new soldering iron and hot air station. I'm gonna review it on my channel. Make sure you guys stay tuned, are subscribed, are following along with the content, because I will be testing that out, see if it's any good. And the soldering iron station, one iron is $100. Hot air, $150. And it's supposed to be better than the add-in, which I'm using right now. And if it's legit, I'm going to switch to it full time. So, keep that in mind. So you stuck around here to the end, there you go. You have some behind the scenes news. Maybe in the next video I'll share the next thing that's on the way too for review as far as tools. Alright, pretty much it's prepped. Now I'm going to use chem wick, solder wick. This is amazing. It's really thick. Not thick, but like strong. It doesn't fray, and it picks up solder really well. So let's take a look. So what I like to do is trim off the used wick, maybe about 5 millimeters. I just made that up. I don't know what 5 millimeters is, but a small piece. And then press it down, wait a little bit, let the heat soak up, and then you can start brushing. You can see how easy this wick does the wicking. Now you do have to have a solid soldering iron to do this. I highly recommend a knife tip, because that one you have a lot of surface area to do the heat transfer from your iron to the wick and through the board. So as you can see, it's sucked up a lot of solder, so we snip off 5 millimeters. Actually, 5 millimeters might be way smaller. So do the same thing. Make sure you have plenty of flux on the board as well. Then now the way I have this board on the board holder, you have to be careful with downward pressure because you don't want the board to bend. And like I said, I did use 1/38 solder wire. I have no idea if it's actually 1/38, but I'll link it down below. What that does is that makes the pads really have low melt solder, which makes it really easy to wick as well. So that, you know, the ground pads are really stubborn, but with the low melt, it helps with that process, with that issue. So here we are. Wicking and cleaning the board. So yeah, support the channel. Links, check out all the links. You know, the course. We have a micro soldering course, a beginner course, an advanced course. Beginner course covers HDMI, iPad charging ports, and Nintendo Switch charging ports, and other easy stuff like that. Great for any repair shop who's looking to just keep those simple repairs in house. Currently, if you sign up, it's normally a 30-day program, but you sign up and let them know Jesse from VCC Board Repair sent you. You know, I am part of the program, but I'm not the owner of it. And if you talk to Ben, tell him Jesse sent you, then he'll give you an extra 30 days for free. So essentially 60 days of training with me, Ben, and the other coaches, you know, giving you tips and tricks, guidance on, you know, what you're doing wrong. You know, we get a lot of students who, you know, they try to learn by themselves and then didn't have any solid mentors to kind of correct them on certain things, or getting the right tools, or why is this, you know, why isn't the solder melting? Why isn't my iron working properly? Okay, so yeah, the course link down below. You know, that's the beginner course. The advanced course is a lot of me, where I help you solve a lot of data recovery, no power, baseband, no touch, more advanced stuff that requires, you know, reballing chips, going deep in diagnostics. You know, so check them out. And it depends on what you want to do with your business. We have a ton of students who, even though it's a 30-day program, after the first week they're already doing repairs for customers. You know, so and pretty much made the money back right away. You know, there's pretty much two approaches to this. Is try it yourself, which I did. I mean, I'll be honest, I learned on my own, but there was also no solid programs back then. There was a lot of trial error. There was lots of making tons of posts as far as, you know, what I do here, what I do there, and then, you know, get a bunch of odd advice from all kinds of people, and, you know, trying to figure out who's right or which ones make sense. But yeah, it is possible to learn by yourself. But do you want a shortcut? That's really the question. Are you willing to pay for a shortcut to learn what, you know, takes, which could have taken, actually I do remember looking for a course, but I really couldn't find one. So I was kind of on my own. All right, so there you go. That's the board that's prepped for CPU swap. Yeah, there's some missing pads, but you can tell they're NC because there's no traces or vias underneath. So that's why you can just ignore them. If you pay attention to that and then take a look at ZXW, you can actually see, you know, they kind of line up. These blue ones are NC, and they basically mean no connection, no circuits. I don't know. The gray ones are ground, and the yellow ones are critical paths. Pretty much all the yellows are required, unless it's a duplicate. So like this one, if this one's damaged but this one's still there, you might get away with just, you know, covering that one up, as long as the line's not shorted. So as you guys saw, this line was shorted, but it was because of these caps over here. There's probably this line shorted too, but I didn't check it. It was already physically damaged. I hope you guys enjoyed the video. I hope you learned something useful. I hope you guys use this technique to your benefit. So there you have it, the VCC grinding technique. Here's what the board looks like now. And in theory, this should be pretty much almost ready to go for CPU swap. We still gotta remove the NAND. The EEPROM is actually in this chip over here. So we're gonna use a programmer to read and write, and then we'll start on the actual board later on. So appreciate all you guys who stuck around here to the end. Make sure you guys are smashing the like button, subscribing to the channel. Links down below for donor boards for this ugly Christmas sweater. All the tools I use in today's video. You know, here's the broken CPU. So I do want to hear you guys' feedback. I want to hear what you guys learned from today's video, and I do want to see you guys in the next one. Thanks for watching.